In this exercise, we're going to go ahead and configure software RAID in Linux. Specifically, we're going to set up disk mirroring, RAID level 1. So the first thing to do according to step 1 in the exercise is to start the Kali Linux virtual machine and then log into it directly with username of Kali, with the password of Kali, or you can do what I've done and of course start up the virtual machine, start the SSH daemon and connect using PuTTY, which is what I've done. Now in step 2, the next thing we want to do is run sudo lsblk list block devices --scsi. We have to know what we have to work with here in terms of disks. And what we're interested in is the fact that we've got SDA1, the first SCSI disk, SDB, the second disk, and SD3. Now we could also, if we wanted to, run sudo fdisk-l to list how the disks are partitioned. For example, dev SDA is the first SCSI device that's carved out into 3 partitions, SDA 1, 2, and 5. That's where the Linux OS is running. But dev SDC doesn't have anything on it. It's about 5 gig, not very big for this exercise. And if we go back up, SDB is also about 5 gig and not carved up into anything. So SDB and SDC, that's where we're going to create a disk mirror between those 2 disks. So in step 3, what we have to do is we have to create disk partitions. So sudo fdisk/dev, and we'll start with /sdb, and I'll press enter. Now, I'm going to press N for a new partition, and I'm going to press enter 4 times, which is going to create a primary partition that uses the entire disk, SDB. Now, once I've done that, I'm back at a command prompt here for fdisk, not the regular Linux command prompt. So what I want to do at this point is press T to change the type of partition. And I'm going to put in a hex code of FD to set it to Linux RAID auto detect. And that's what it returns back to me. And I'll press W to write that to the partition table for SDB. Now, I want to do the same thing once again, except for the next disk, which is going to be dev/sdc, meaning I want to press N for new partition and press enter to accept all the defaults, T for changing the partition type, FD for Linux RAID auto detect, and W to write that to the partition table. That's step 6 in the exercise. Now, step 7 has us verify some of this by running sudo fdisk-l list /dev sdb /dev, one of you both of them, SDC. What we're looking for under the type column is that it says Linux RAID auto detect, in this case for partition SDB1, as well as for SDC1, Linux RAID auto detect. Okay, perfect. Next thing we want to do in step 8 is make sure that we have the correct tools installed here so that we can work with software RAID. So in step 8, we're instructed to run sudo apt-get, which is used to install packages, install mdadm, and it says, do you want to continue? I'll type in the letter Y for yes, and I'll press enter. Now, if you don't have internet connectivity, you're not going to be able to pull this from the default package repositories. So in this case, I do have internet connectivity, so it's just going to pull down that tool so that we can then continue with step 11 by enabling software RAID. If I get prompted to restart any services, I'm just going to go ahead and press enter to accept those defaults. All right, so I'm going to run clear to clear the screen. And what I want to do at this point in step 9 is create a software RAID 1 mirroring disk configuration. And I'll do that by typing sudo mdadm --create. And the next thing I'll do is specify /dev/md1, mirrored device 1. That's the logical mirrored device I want to create. --the RAID level equals 1, disk mirroring, --raid-devices. Now I got to specify them. I'm going to tell it that I have 2, so equals 2, space /dev/sdb1, that's the partition, first partition on that, and then space /dev/sdc1. Remember, we carved out those 2 disk partitions and flagged them as Linux RAID auto detect. Remember that? Okay, so let's go ahead and do that. And I'm going to go ahead and press enter. Continue creating array, it asks. I'll type in the letter Y for yes, and I'll press enter. Now, once that's been done, in step 11, we're going to verify our work by typing sudo mdadm -- detail/dev. Remember we made that logical device md1? And looks good. We've got an active sync between dev sdb1, sdc1. Okay, excellent. So far, so good. At this point, we have a mirrored disk partition. Now, what we're going to do is make sure it's accessible as a file system type of environment. And so in step 12, we're going to create a directory, sudo make dir / let's say customer transactions, cust_trans. So what we want to then do is mount the file system to make sure that it is accessible. So we know what to do here. We want to run clear, first of all, sudo mount. Now what I want to mount is /dev /mirror device1 md1, and I want that available through space /cust_trans. Now notice I get some kind of an error about the wrong file system type and so on. Well, that's because we've got partitions. They're not formatted. So I'm going to run sudo makefs to make file system -t for type ext4 /dev /md1 mirrored device 1, and I'll press enter. And it's on its way. So now that we have a usable file system, and you have to format a partition before it can be used, let's try once again to mount. So I'm going to clear the screen. I'm going to use the up arrow key to go back up to sudo mount. This time, no problem. So according to step 13, files can now be added to the cust_trans folder like any other normal file system folder. And we can verify that the mount point is mounted correctly by typing sudo mount, and I'll pipe that to the grep line filter looking for /dev /md1. And indeed, it's mounted with rw read write and available under /cust_trans.